So let's explore DataLoader. I've created a new Jupyter notebook for this, and we'll import our usual suspects, create a random number generator, and let's copy our implementation of our toy dataset from our old notebook to this new one here. And now we'll create a new data loader, but for that we need to create a dataset first, and we'll create a small dataset with just 5 rows and pass it to the data loader's constructor. Now let's iterate through the data loader and see what we get. So data loader typically yields a batch, and in our case a batch is made up out of a tuple with a row of X and the label Y. And just for comparison, let's print out each row from the dataset directly as well. And I'd like to draw your attention to 3 things here. First is that the data loader seems to be giving us rows in the same order as the dataset itself. So unlike what we learned in the last video, there doesn't seem to be any sampler who's sampling the data. Second, the data loader seems to have added an additional dimension to each row. So the dataset was giving us a single dimensional array, whereas the data loader seems to be giving us a 2-dimensional array with 1 row and 1 column. And you can see that happening to the Y values as well, which turned into a 1-dimensional array from a scalar. And the third is that our NumPy arrays seem to have been converted into torch tensors. From the last video, we know that the data loader has a sampler and a batch sampler. So let's examine those and see if we can explain these 3 things. So first we see that data loader seems to have created a sequential sampler, which might explain why we see the data appearing in the same order as the data source. Now from the last video, we know that the batch sampler should hold a reference to the sequential sampler. Let's verify if it's actually the case. And sure enough, we see that the sampler held by the batch sampler is the same sequential sampler. Next, we see that the batch size has been set to 1 on the default batch sampler, which tells us that the rows returned by the data loader were in fact batches, and that explains why the additional dimension was needed. Finally, in order to figure out why NumPy arrays got converted into torch tensors, let's turn to the documentation. The thing that's responsible for this is the Collate function. The default Collate function simply converts NumPy arrays into PyTorch tensors. And don't worry about this automatic batching is disabled or enabled. We'll look at all of that in a lot more detail later on. But suffice it to say that regardless of whether this is enabled or disabled, Collate function will automatically convert NumPy arrays into PyTorch tensors.